This situation is slightly complicated, but we won't stop here and we will get over to the next topic, which is resistance. And for resistance, if we are supposed to define a form, we need to know that distance resistance final minus resistance initial is directly proportional to resistance initial, and it's also proportional to this difference is also proportional to temperature. Combining the two, R minus R naught is proportional to R naught T. RF is proportional to RF. RF minus R naught is equal to, now putting the constant of proportionality alpha R naught T. So RF or RT can be used interchangeably because resistance and a certain temperature to the standard one is the final in this case. So what we do is we simplify the notations and we do something simple here. RT minus R naught, RT minus R naught. Okay, so now RT becomes equal to R naught plus alpha R naught T, and RT becomes equal to R naught into 1 plus alpha T. Yes, so this is the form which can be iterated into RT by R naught. The ratio of the final to the initial reference resistance is equal to 1 plus alpha T. Alpha is the constant of proportionality is T, and T is the temperature. And then we can get into the mathematics if needed. And the cases are that there are resistances in either series or parallel. So for series, we have a situation where, let's say, the resistances are put like this: R1, R2, and so on, plus, minus, and here goes the current, and here we have the voltages V1, V2, and if needed we can expand the circuit to the required number of resistances. So in this case, I1 is equal to I2 is equal to up to IN is equal to I. So there's no splitting of the current, but there's splitting of the voltages. So total voltage is equal to V1 plus V2 up to Vn. And we know that V is equal to IR equivalent, the total one, and V1 is equal to I1 R1, and V2 is equal to I2 R2, and so on. Okay, so what we do now is we get into further development. which is that IR equivalent is equal to I1 R1 plus I2 R2 plus up to IN RN. Okay, so what is happening here is IR equivalent is equal to I taken out as common because it's the same throughout the circuit, R1 plus R2 plus up to RN, and I cancels out with I, so R equivalent, the total resistance becomes R1, the equivalent resistance for the circuit in totality, R1 plus R2 plus up to Rn. So this is a form of interest here. Okay, and after that we have this thing in parallel. Now we discuss the resistances in parallel, and the situation is R1, R2, okay, and we have this current here, and this splits into I1 and this here I2, and we have the same voltage across the capacitors. So set, so V1 is equal to V2 up to Vn is equal to V, but I is equal to I1 plus I2 plus up to In, depending on the extension of the circuit. So I is equal to V by R, as we know, V by R equivalent. So I1 is equal to V1 by R1, and I2 is equal to V2 by R2, and so on. And so V by R equivalent becomes equal to, since the voltage is the same, V by R1, V by R2, V by R1 plus V by R2 up to V by Rn. So V taken out of the summation as a factor, 1 by R1 plus 1 by R2 plus up to 1 by Rn. Okay, this cancels out those, therefore 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus up to 1 by Rn. So this is the equation of interest here, and it is important in applications. Now we look into electric power. Electric power so power is equal to P, which is equal to power speed is equal to work done by time. Work done in the electric circuit divided by time. This is the electric power. So, and work done as established is also equal to charge times voltage, which can be explained in some other segment. So P becomes equal to QV by T. Yes, and I is equal to Q by T. Current is charge divided by time. Yes, charge divided by time. So carefully, P is equal to VI. Yes, and I is equal to P is equal to VI and V is equal to IR. One more trick. Voltage is equal to current times resistance. Okay, so we substitute we substitute V, so P becomes equal to V. P becomes equal to I or I, which is I square R. Yes. So two things are important here. P is equal to IV and P is equal to I square R for power. And that's it. Now we touch a little bit on the magnetism, just a little bit, not much, because this is somewhat enough for tonight. So magnetism, and magnetism says that the magnetic force is directly proportional to current, is directly proportional to length of the coil, is directly proportional to the magnetic field, it is directly proportional to the sine of the angle involved. Okay, so if this is the coil, here we have the battery, the circuit, it's the flow of the current, and then there is this three-dimensional law which says that if electric field is here and the magnetic field is here, and then the, I don't know, force is somewhere here, but that can be explained later. So what we do is we combine these proportionalities. FP is directly proportional to ILB sine theta, and FP is equal to KILB sine theta, and K is equal to 1 in system international of units. So FB is equal to ILB sine theta. And in the vector form, we have ILB sine theta and cap. So this is a form here. And we can also discuss the flux, which is non-uniform. Excuse me. The flux, basically magnetic flux. Magnetic flux which is phi b, which is equal to magnetic fields times area as dot product, and phi b is equal to ba cos of theta. Yes, the cosine of the angle involved. So for a non-uniform surface, I mean, there is this general form that phi bn is equal to ba n cos theta. Delta A. So what we do here is we put this magnetic flux as the issue here, and we put this phi b total is equal to phi b1 plus phi b2 plus up to phi bn, which basically means that it is equal to phi b is equal to phi uh, b magnetic field delta a 1 cos theta 1 plus b delta a 2 cos theta 2 up to b delta a n cos theta n. Okay, so what is happening here is that theta 1 is equal to theta 2 is equal to theta n. It is roughly equal to theta. So cos of theta comes out, phi b is equal to cos theta, and now b outside, because the field is also common and the value is very much the same for the field and the angle aspect. So what we are left with is inside the summation, the I is equal to 1 up to n delta a I, yes, which means delta a1 plus delta a2 up to delta an. So this is the situation. So, and phi b, simply put, cos theta b a as summation I is equal to 1 up to n delta a I is equal to a, roughly total area. So these are the basic forms, and we will develop further, but for now it is over.